Okay, welcome back, everyone. So let's continue with uh, what we had going on with the musculoskeletal system. So the skeletal muscle is is or is not striated. It is striated, and the other ones are not striated. Smooth muscle and cardiac, they are not striated, right? So let's see. Actually, cardiac muscle is also striated, but smooth muscle is just like a cell. And both smooth and cardiac are single nucleus, and cardiac is branched, and smooth is tapered, non-branched, and skeletal is non-branched. Skeletal has multiple nuclei and striated, and voluntary and involuntary. This is a cardiac muscle. This is skeletal muscle, and these are smooth muscle. Single, very long, cylindrical, multinucleate cells with obvious striations. Branching chains of cells, uni or binucleate striations. Single chain, fusiform, uninucleate, no striations. Smooth muscle cells, skeletal muscle cells, and cardiac muscle cells. Okay, now let's look at I wanted to ask from ChatGPT why is skeletal and cardiac muscles striated? So skeletal muscle is composed of long during muscle contraction, these filaments slide past each other, slide in filaments, leading to shortening of sarcomeres. The striations in both are essential for their contractile function. But smooth muscles, we don't need them to contract. So we don't need smooth muscles to contract. Which is a stupid question in my opinion. Play a crucial role in the body and they do contract. Unlike skeletal muscle and cardiac, smooth muscles lack this striated appearance as the organization of filaments is not as regular. They are regulated. Cardiac muscles are regulated by the cardiac conduction system. So it should be autonomic, involuntary. However, smooth muscles are regulated by autonomic nervous system, ANS, but the cardiac conduction system is different, apparently. However, both are involuntary, right? Involuntary, involuntary. Okay, we got this right. Striated muscle tissue is a muscle tissue that features repeating functional units called sarcomeres. Nice. We have the mesoderm stuff going on. We have muscle, skeletal, voluntary, voluntary here, striated, multinucleated, striated, uninucleated, but branched, and smooth muscles are uninucleated, unstriated, And we have type 1, which is a slow fiber, type 2A fast, type 2B for type 2A. Type 2B is faster than type 2A, and type 2B is for anaerobic, fast to fatigue, quick bursts. But type 2A is for intermediate. And type 1 is slow aerobic, slow to fatigue, endurance, many capillaries, increase oxygen supply. And here you can see we have the T-tubule stuff going on. So acetylcholine is released, sodium comes in, calcium comes in from the sarcoplasmic reticulum to T-tubules. It binds to troponin, right? We have the troponin here. We have the actin filaments here. No calcium resting, tropomyosin. And then when calcium comes in, it attaches to the troponin, and the troponin just the troponin these actin filaments have myosin binding sites, and the binding of calcium to troponin changes the conformation of tropomyosin, and that leads to the exposure of the binding sites. So the myosin head attaches to that, and the cross bridge, this sliding filament happens, and then ATP comes and relaxes the muscle, detaches the myosin head from the. So here we have the myosin binding blocked by tropomyosin. Yes, head bound to ADP and in high energy position. Then we have power stroke. We have cross bridge formation here. So cross bridge formation, calcium binds troponin and moves tropomyosin from binding sites, and actin myosin binds. And the power stroke release ATP, ADP, and PI. Sarcomere shortens. So when myosin head is not attached to in the inactive state, the resting state, ADP is attached to the tropomyosin head, ADP and a PI, right? And once the power stroke happens, now you want to just relax the muscles. So then you have the cross bridge dissociation, and the ATP binds the myosin head, and myosin head releases actin. Low energy position. The high energy position is with ADP and PI. So you have a high energy position, so you want to contract the muscle, right? But then the low energy position is basically allowing you to relax, and that's when you have ATP bound to the myosin head, and the ATP is hydrolyzed, returning to high energy position bound to ADP when you want to contract the muscle again. So calcium is present, which equals contraction, and none equals stay in resting. Great. Central canal, eversion canals, lamella, perforating canal, Walkmans. We didn't have Walkman on our overview sheet, so we can add it later. Epimysium, neither that. Fasciculus, fascicle, muscle fiber. We have the tendon, myosin. Actins are just these thin filaments, right? Actins are like these polymers, right? Dimers, polymers. So what is actin made of? Globular proteins, yeah. These monomers, individual subunits called monomers. And these monomers polymerize to form long filamentous structures. The monomeric form of actin is often referred to as G-actin, globular actin, and the polymerized form is known as F-actin, filamentous actin. Nice. Okay, let's continue. Skeletal muscle is under what control? It's under voluntary control, somatic control. Skeletal muscle is so we know smooth muscle is uninucleated. Skeletal muscle is multinucleated. Yes. And cardiac muscles are also uninucleated. They give us a pseudo feeling that they might be multinucleated, but they're not. They're branched, and that's why we kind of get illusioned by that, disillusioned by that. What muscle pairs are those whose actions oppose each other? Antagonist muscles. I just knew that. We didn't have it on the overview, but yeah. Opposing pairs, flexors, extensors, and abductors and adductors. Adduction, adding it, is adding it to your body, comes close. Abduction, you just remove it away. Right? Okay. What color skeletal muscle fibers are slow twitch? Is it red or white? And carry out oxidative phosphorylation. Since it's red, it has RBCs and can carry the oxidative phosphorylation. So it's red skeletal muscle. The red color is from myoglobin, which binds oxygen. Oxidative phosphorylation, you bring in the oxygen. And finally, it goes into the electron transport chain where you have oxygen as the molecule you want for acceptance of protons or moving of protons. We can get into ETC later. That's a plan. So don't worry, they'll get to that. And that will be for the biochemistry chapter, right? The red color is from myoglobin, yeah. So long distance running, we had red, lots of red slow twitch, red fibers. For middle distance is a mixture, but it's mostly white. It's like type A. For sprints, we have type B, type 2B. So these are white skeletal muscles that are fast twitch and carry out anaerobic metabolism. What muscle forms the supporting tissue of blood vessels in hollow? Was there something for this? No. Like why they are white? Why are white muscle that color? Fast twitch. Give a name for the pale appearance, which is due to a lower concentration of myoglobin. So they still do have myoglobin, but it's in a lower concentration. The color of muscle is influenced by the amount of myoglobin present, and muscles with higher myoglobin content tend to have a redder color. Adapted for short bursts of activity and RC with generous energy without the need for oxygen to ensure is in contrast red muscles which are suited for sustained aerobic and higher myoglobin content. Yep. What muscle forms type the supporting tissue of blood vessels and hollow internal organs? So that will be smooth muscles, right? Such as the stomach intestine. That's smooth muscle found in the walls of hollow organs, arteries and veins, airways, uterus, entire GI tract, bladder, ureters, iris of the eye. Cool. Smooth muscle is considered smooth because when you touch it, it's smooth. It does not have these striations. Okay. It's smooth because it doesn't have the striations. Smooth. Fusiform. What is that? What is fusiform for with respect? Let's ask it first. It might be something else. Spindle shaped or elongated in tapering form. It is often applied to objects or organisms that have a streamlined and cylindrical shape, wider in the middle and tapering towards the end. The term is commonly used in various fields, including anatomy, biology, and engineering. Fusiform body shape is common in many fast-swimming fish. This streamlined shape reduces drag in the water, allowing for efficient and rapid movement. Examples of fish with a fusiform body include tuna and mackerel. In plant biology, the term fusiform can be used to describe the shape of certain cells or structures that are elongated and taper at both ends. The term fusiform in astronomy has been used to describe certain celestial shapes, such as the elongated form of some galaxies. In engineering, the term may be used to describe certain shapes of structures or objects designed for aerodynamic efficiency, such as fusiform bodies in underwater vehicles. Interesting. Okay, let's do this again. Smooth muscle is under involuntary control, autonomic control. Smooth muscle is uninucleated. What type of muscle is an involuntary striated muscle? They consist, cardiac muscles, walls of the heart. It constitutes the main tissue of the walls of the heart, found only in heart and tips of blood vessels. Do not fatigue, controlled by central nervous system and pacemaker cells. Amazing. This is a cardiac muscle. It's branched and uninucleated. Branched chains of cells, uni or binucleate striations. It can be also binucleated. Interesting. But here we have a single nucleus. Okay. Cardiac muscle is under involuntary control, autonomic. Cardiac muscle is uninucleated. It can sometimes be considered binucleated. Interesting. Cardiac muscle cells are connected with what that contain what? They are connected with branches that contain gap junction. Okay, intercalated discs. Sorry, yeah. So let's zoom in on the heart. We have intercalated discs, and these are here, and these intercalated discs connect the cardiac muscle cells, and they contain gap junctions. So these gap junctions, you can see them like this here, and we call these projections, like branches, desmosomes. And the cardiac muscle fiber is like this. You have a cross section here, and this is their nucleus. And in between them, you have all these actin and myosin filaments, and you have even mitochondria in between them. Cool looking structure. Gap junction, drawbridge gap, found in heart on defibrillator. Interesting. Okay, let's do this again. The skeletal system is derived from what germ layer? It's mesoderm. You know that? Can I remember what was the picturized for this? Mesoderm, skeletal muscle, like the lion and thing? No, it's skeletal system. Yeah. No, man, this is no way going to happen for me. What skeleton includes the skull? So this is the skull, vertebral column, rib cage. These are axial skeleton. So appendicular is everything surrounding it. These are axial, right? Cool. Yep. Then limbs, pectoral girdle, and pelvis are appendicular. Appendicular. So it's these in the middle here. These are axial. The rest is pelvic girdle, the pelvis, pectoral girdle. Where is pectoral girdle? Shoulder girdle. Bony structure provides attachment point for the upper limbs, arms, and vertebrates. Clavicle, composed of two main bones: clavicle, collarbone, and scapula. Triangular bone. So pectoral girdle is the clavicle plus the scapula. The shoulder girdle in the limbs. These are appendicular. What bone, also known as cortical bone, is a dense material used to create much of the hard structure of the skeleton. This is a compact bone, the hard structure. Cortical bone, compact, cortical. Let's write it in our notes. So we had compact bone here, and we need to write aka cortical bone. Nice. Oh wait, let's take a look at this. We have the periosteum, which is the membrane covering the bone. We have blood vessels coming. We have the bone marrow in the middle. We have medullary cavity. Apparently this is also has the name medulla inside it, but it's the medullary cavity. Then we have epiphyseal plate. Then we have cortical hard bone. Oh, this is around it. Then we have trabecular spongy bone. And then we have articular cartilage in the middle. So the rounded, the hard part, the hard structure part, is cortical or a compact bone. What bone, also known as cancellous bone or trabecular bone, spongy bone, is a very porous type of bone. It has holes inside it located at the ends of the long bones, the epiphyses, with harder compact bones surrounding it. So it's these are spongy bones, right? Okay, apparently I cannot get a pronunciation of this, but I mean we can write it here. P. This is. I hope that's how you say it, right?
Epiphysis.
Epiphysis. I don't trust you, man. Pronunciation.
Epiphysis.
Epiphysis, just as I said it. So these are spongy bones, trabecular or cancellous bone. Let's see, spongy, cancellous, trabecular, aka how do you write it? Is it A? Trabecular. Trabecular. Cool. What is the thin membrane that covers many of the bones in your body? This is periosteum, right? Yep. What produces the cellular elements of the blood, including platelets, RBCs, and white BCs? This is the bone marrow. Specifically, is it the red or yellow? Is the red bone marrow? Yeah, bone marrow, blood vessels, hard bone, ear pockets, ear cartilage, and bone marrow in the middle. What bones are hard, dense bones that provide strength, structure, and mobility? So, what types do we have? This should be something like skeletal bones or no, like compact bones, no, long bones. These are hard, dense, and strength, structure, and mobility provide long bones. Some bones in the fingers are classified as long bones, even though they are short in length. Spongy bone, medullary cavity, compact bone, epiphyseal line, and the whole thing is long bone. What attaches bones to other bones? Is it the tendons or is it ligaments? It's the ligaments that connects bones to bones. Joint capsule ligaments bind bone to bone, and tendons bind muscle to bone. Supporting is involved with movement, blood propulsion, and thermoregulation. It's the skeletal muscle. Attaches bones to muscles, tendon. Bone tissue is also known as what tissue? Skeletal tissue, osseous tissue. Also called osseous tissue. Strong calcified calcium salt deposits, resists shattering, flexible collagen fibers. Matrix here, central canal, blood vessels, osteocytes. This is amazing, man. How did God come up with this? What is the chief structural unit of compact cortical bone? So it's osteocyte. Osteon consists of concentric bone layers called lamellae, which surround a long hollow passageway, the Haversian canal. So we have the organ level, we have the cortical bone, and these are called osteons. They contain both the lamellae. They consist of concentric bone layers called lamellae, and the Haversian canal in the middle, and the osteocytes are just between these layers. The whole thing is called the osteon plus the osteocytes plus the Haversian canal plus the lamellae is called the osteon. And these are chief structural units of compact or cortical bone. This is similar to sarcomere being the chief structural unit of our muscles, skeletal muscles. Osteons consist of concentric bone layers called lamellae. So we have osteocytes and lacunae. Lacunae are probably like these spaces between lamellae, right? We have concentric. This reminds me of the woods, right? Like the woods that you cut and in the jungle you see, or whatever of the trees, the tree trunks. Concentric lamellae is here. Blood vessels, Haversian canal, osteon, cross section of a Haversian system. Cross section of a Haversian system, sure. Osteons consist of lamellae. What surrounds blood vessels and nerve cells throughout bones and communicate with bone cells through connections called canaliculi? Yeah, I'm not sure. I want to say virgin canals, but I'm not sure. So it surrounds the blood vessels and nerve cells throughout bones and communicate with bone cells through connections called canaliculi. Canaliculi. What are small channels that link together the lacunae in bones? Is it the lamellae? The small channels? Canaliculi? So canaliculi are the small channels that connect the lacunae. Osteocyte in the lacunae. Lamellae are these layers, and lacunae are the spaces in between the lamellae. And the central canal is here, and the virgin canal, and the lacunae are just these spaces. So what canaliculi are the canals, the canals, well, however you say it. Osteoblasts become lacunae when they encase themselves in bone matrix. So it's the osteoblasts that build bone. They become lacunae when they encase themselves in bone matrix. So when they come to the bone matrix, they become lacunae. Compact bone is composed of osteons, which are made up of lamellae, rings of bone matrix. Lamellae surround a central virgin canal, which contain blood vessels and nerves. Lacunae are spaces in the lamellae matrix. Amazing. Osteoblasts are trapped here and become mitotically inactive to give rise to osteocytes, which crush bones. Within each osteon, lacunae connect to one another via channels called canaliculi needed for communication. Osteoclasts are formed in the bone marrow and tend to be found near dissolving bones. Osteoblasts are also formed in the bone marrow and tend to be found on the surface of the bone. They form osteoids. I hate bone too, but I think that's all we need to know. Yeah, I mean I hate it too, but honestly, it's a cool freaking structure. I'm starting to love it, and osteoids is the only thing that I did not come across here. So these osteoblasts are formed in the bone marrow and tend to be found on the surface of the bone. They form osteoids. So osteoids are like so is osteoid the same as osteon? No, osteoid and osteon is different. Osteoid refers to organic unmineralized matrix of bone tissue. Osteons, also known as virgin systems, are the structural units of compact bone. Osteoid is primarily composed of collagen fibers, proteoglycans, glycoproteins, and other organic components. It provides the framework or scaffold upon which hydroxyapatite crystals, mineralized components, are deposited to form the hardened bone tissue. Osteoid becomes mineralized over time as calcium and phosphate ions are deposited, turning it into mature bone tissue. Osteons are the virgin systems, structural unit of compact bone. Each osteon consists of concentric rings of mineralized bone, so osteons are mineralized bone matrix lamellae surrounding a central canal, but osteoids are not mineralized yet. And the central canal contains blood vessels, nerves, connective tissue, providing pathway for nutrient exchange and waste removal within the bone. Osteons are arranged in a repeating pattern, and their structure contributes to the strength and durability of compact bone. So, where is osteoids? When osteoblasts when osteoblasts are formed in the bone marrow and they go to the surface of the bone, the compact bone. That's where they form osteoids. However, they are unmineralized. They are composed of collagen fibers, proteoglycans, glycoproteins, stuff like that. Did we answer this correctly? Kinetic are small chains. I think so. Let's do it again anyways. Osteoblast builds bone. Osteoclast reabsorb bone. Osteoblasts mature into new osteocytes. Osteocytes are mature permanent bone cells. Osteoclasts resorb old osteocytes. So osteoblasts mature into osteocytes. Osteocytes are mature permanent bone cells. And osteoclasts resorb old osteocytes. What is a connective tissue that is firm but flexible and connects bones together? So firm and flexible, connecting bones together. We expect it to be ligaments, but it's cartilage because it's firm and flexible. It is firm. Is it flexible? I think so. Articular cartilage. I think we have it in our nose too. It's firm but it's flexible. Cartilage is what and what? Firm and flexible. Avascular and aneural. So no blood vessels and no nerves. They lack nerve fibers, not innervated. Avascular withstands tension and compression. Tough but flexible. Ground substance. Collagen fibers, elastic fibers, water allows cartilage to rebound after being compressed. Nourishes the cartilage cells. Chondroblast reduces new matrix. Chondrocytes found in small groups within cavities lacunae. So lamellae are those layers, and lacunae are the spaces between them. What joints are fused together to form sutures? Are these gap junctions? Immovable joints. What am I even talking about? I'm not even thinking. So immovable joints are fused together to form sutures. So we have immovable or fixed joints, fibrous, and the movables are synovial. Immovable, fibrous. Fibrous. These joints are held together by tough tissue which develops during childhood. Examples include the cranium, pelvis, and vertebrae. These are immovable and fixed. Slightly movable, cartilaginous. Here movement is needed but only to a certain point. Vertebral column. Individual vertebrae are separated by cartilage. So we have immovable, movable, synovial fluid. Freely movable joints, synovial. These joints are also called synovial and allow movements to take place. There are 6 types of freely movable or synovial joints. Let's actually write some notes here. So these movable examples are strengthened by ligaments containing a synovial capsule. Like semi-movable, slightly movable, cartilaginous, semi-movable joints, vertebral column, let's have it here. Cranium, pelvis, vertebrae, three movable joints, synovial. Is it important to know that there are 6 types? No, I don't think so. What else? What joints are strengthened by ligaments and contain a synovial capsule? These are movable joints. Synovial capsule. What fluid lubricates joints and permits smooth movement? It's synovial fluid. You have it here. Joint cavity containing synovial fluid, synovial membrane, articular capsule, articular cartilage, and bone. What is the process of laying down new bone material by cells called osteoblasts? So ossification is the process. Yes. Making osteoblasts. Laying down new bone material by cells called osteoblasts. So they lay down new bone material. These osteoblasts. Intramembranous ossification in flat bones of skull. Endochondral ossification in all other bones. So in our skull, it's intramembranous ossification. And ossification, endochondral ossification everywhere else. Did we have ossification anywhere here? No. Bones from cartilage formed through endochondral ossification, skull bones. From mesenchyme in intramembranous ossification. What are the functional units of muscle? Sarcomeres and are composed of long fibrous proteins as filaments that slide past each other when a muscle contracts or relaxes. Sarcomeres. One sarcomere, multiple end-to-end sarcomeres give myofibrils, and myofibrils give a muscle fiber, right? Osteoblast build bone, osteoclast breakdown bone, osteocyte mature bone cells. PTH and calcitonin effect on osteoclast. To crush bone or not, right? Two of the important proteins in a sarcomere are thin filament and thick filaments, which form the thick filament. So thick filaments, myosin and actin. Myosin, which forms the thick filament, actin forms thin filament. What is the I band? It's the thin filament only. What is the A band? It's and, so it's both of them. It's both myosin and actin, and it doesn't change in size during contraction. It's the only one that doesn't change in size. And there's H band, which is only actin filament. Myosin in the middle, right? H zone. What else? We have the Z line it's the end of the sarcomeres, and we have Z discs, and we have cap Z. Interesting. We have titin, which is actin or whatever. We have the M line in the middle. We had a anatomy professor, Dr. Morales, and he called the Morales line the middle of the muscle fiber. So myosin has here, we have them, and these are titin and actin filaments, and here titin is at the end of the myosin. interestingly. Cool. What protein is attached to the protein what, and the two regulate actin myosin interactions. This is troponin is attached to tropomyosin, and these regulate. So nothing is bound to them in the high energy state. And when calcium comes, they go from relaxed state to the contracting state, where the myosin head attaches to the tropomyosin, the actin binding side on the myosin binding side here that is exposed. So these actins have tropomyosin on them, and tropomyosin is basically these thin lines, fibers that stop the myosin binding sites to be exposed. But when calcium binds to troponin, the conformational change happens and the myosin binding sites are exposed. Beautiful demonstration. From Pearson Education, publishing is Benjamin Cummings. Nice. What smooth muscle is considered smooth? Because it is not striated, doesn't have striations. What defines the boundary of each sarcomere? It's Z lines. What is the middle of the sarcomere? M line. What is the light band on each side of the Z line, comprising a region of the sarcomere where thin filaments are not overlapped by thick filaments? This is the I band. I is thin, right? Oh, sorry. The H zone contains only myosin thick filaments. The A band contains both actin and myosin. It is the only part that does not change in size, maintains a constant size during contraction. Sarcomere is attached. Is there anything else here? No. Sarcomere is attached end to end to become myofibrils. Nice. Each myofibril contains many myofibrils, each muscle fiber, myocyte. So myocytes, skeletal muscle fiber, one muscle fiber, myocyte. Do we have it here? Where is it? Sarcomere is attached to the myofibrils. Each myocyte contains many myofibrils. So here, aka muscle fiber. Cool. Cardiac muscle cells are connected with intercalated discs that contain gap junctions. So intercalated discs and gap junctions are specific for cardiac muscles. What forms a cuff-like structure surrounding myofibril, and its main function is to store calcium? It should be T-tubules, sarcoplasmic reticulum, not T-tubules. It stores calcium, sarcoplasmic reticulums. They're cuff-like, looks like handcuffs surrounding myofibril. T-tubules in the middle, sarcoplasmic reticulum on the side here, terminal cisternae, and the triad, which is the sarcoplasmic reticulum, the cisternae, and the root T-tubules. What is a cell membrane that encloses each muscle cell? The muscle membrane encloses each muscle cell. We had it. Sarcolemma. Yeah, sarcolemma is the cell membrane that encloses each muscle cell. The sarcolemma maintains a what? Much like a neuron does. The sarcolemma maintains membrane potential. Okay, it's like a neuron that we had. The cell membrane potential. So sarcolemma maintains the membrane potential. What are extensions of the cell membrane that penetrate into the center of skeletal and cardiac muscle cells? T-tubules. So transverse tubules, T-tubules, they go deep inside the penetrating into the center of skeletal and cardiac muscles too. That's important to know. Connect carry signals. So basic contraction of striated muscle. See, so both sarcomeres and both skeletal and cardiac muscles are striated. So we have the whole sarcomere structure and everything in the cardiac muscles too. Cool. What bones are hard, dense bones that provide strength, structure, and mobility? These are long bones. If the fingers are considered long bones, muscle contraction begins at the neuromuscular junction, where the efferent neuron releases what? Which binds to receptors on the sarcolemma and causes depolarization. Releases calcium, which binds to receptors acetylcholine. So we have the neuromuscular junction here. Acetylcholine is released to bind to receptors on sarcolemma and cause depolarization. Acetylcholine released from nerve cells attaches to receptors in muscle cell membrane. In muscle contraction, depolarization spreads down the sarcolemma to T-tubules, triggering the release of calcium, Ca2+. Calcium, sodium, open sodium ion channels leading to action potential. Action potential travels along the T-tubules. Thicken T-tubules, the calcium is released from release of calcium from where is this? After the action potential comes, the acetylcholine goes along to the tubules. Wait, so we might have had it here. After signal reaches T-tubules, what does release Ca2+ to bind to troponin? From a structure called sarcoplasmic reticulum. Yes. So the sarcoplasmic reticulums are the storage for calcium, right? Okay, great. What attaches bone to other bones? Ligaments. During muscle contraction, what binds to what? Causing a shift in tropomyosin. So calcium binds to troponin. Yes. Causing exposure of the myosin binding sites on the actin filament. During muscle contraction, shortening of the sarcomere occurs as myosin heads bind to the exposed sites on actin, forming what? And pulling the actin filament along the thick filament. Shortening of sarcomere occurs as myosin heads bind to exposed sites, forming cross bridges, and pulling the actin filament along it. Yes. when the crossbreed is formed, there's ADP and PI attached. When it's released, the power stroke happens, and then the ATP attaches to relax the muscle. Muscles relax when what is degraded by what, terminating the signal. So allowing Ca2 plus to return to the sarcoplasmic reticulum, terminating the signal. When what is degraded by what? Acetylcholine is degraded by acetylcholinesterase. Right. So we have acetylcholines, nicotinic acetylcholine receptors, acetylcholinesterase here, and motor end plate of the muscle, sarcolemma of muscle fiber. Nice synaptic cleft. This is the neuromuscular junction. The axon terminal. The Ca2 plus comes. The Ca2 plus, the acetylcholine. The Ca2 plus comes from the sarcoplasmic reticulum and comes to the neurons, and then these vesicles contain the acetylcholine that attaches to the nicotinic acetylcholine receptors. Bone tissue is also known as fibrous tissue, osseous tissue. What binds to the myosin head, allowing it to release from actin? ATP binds to myosin head. What is when only one muscle fiber responds to a brief stimulus? It's so we have summation. This is not summation. When only one is twitch, right? A single twitch. So a single twitch is when if muscle fiber is re-stimulated after it has completely relaxed. The second twitch is the same magnitude as the first twitch. If a muscle fiber is re-stimulated before it has completely relaxed, the second twitch is added on to the first twitch, resulting in summation. If a muscle fiber is stimulated so rapidly that it does not have an opportunity to relax at all, to stimulate a maximal sustained contraction known as a tetanus occurs. The tetanus is just like so many stimulations at the same time, twitches, right? So and the muscle does not have time to relax, and the maximum sustained contraction, known as tetanus stimulation, ceases or fatigue begins. Nice. Frequency summation is the addition of signals before the muscle has a chance to fully relax the stimulations. Multiple simple twitches, addition of multiple simple twitches. Frequency summation in muscles. What adds a phosphate group to ADP, forming ATP? It's a kinase. Should be kinase, like creatine phosphate. Adds phosphate during exercise. Creatine phosphate used up. Muscle contraction. Creatine phosphate attaches phosphate, adds a phosphate to ADP, forming ATP, and gives out creatine, right? That's why all these athletes drink and consume creatine monophosphate, right? To be able to exercise better. What is the chief structural unit of compact bone or cortical bone? Is osteon. It consists of lamelles, haversian canal. The lamelles surround the long hollow passageway, which is the haversian canal. Osteons are also known as haversian systems. What surrounds blood vessels and nerve cells throughout bones and communicate with bone cells through connections called canaliculi. It's the haversian canals, canaliculi, and communicates with bone cells through connections called canaliculi. In neurological terms, what are the spontaneous firing of a motor unit? Twitch, fasciculations. With fasciculation, only one or few of these units fire. Fasciculations can be caused by something as simple as drinking too much caffeine, a brief spontaneous contraction affecting a small number of muscle fibers, often causing a flicker of movement under the skin. It can be a symptom of disease of the motor neurons. Fasciculation is occurring in disguised calves. What commonly known as floppy baby syndrome is a state of low muscle tone, hypotonia, decreased muscle tone. What refers to below normal or absent reflexes? Hyporeflexia is the opposite of hyperreflexia. 3 reflex responses: hyporeflexia, hyper, normal, increased movement, lesion in the spine above the level of the reflex. Hyporeflexia, absent or decreased movement, problem in peripheral nervous tissue, trauma, impingement, or entrapment. So hyperreflexia is much the hyperreflexic individuals. Patients must have a lesion in the spine above the level of the reflex. It can be detected through the use of a reflex hammer. When the what reflex is activated, the stretch muscle and the supporting muscles are contracted while the antagonist muscles are inhibited, relaxed. This is the stretch reflex. The stretch reflex, myotatic reflex, is a muscle contraction in response to stretching within the muscle. Cell body of sensory neuron, interneuron, efferent impulses cause contraction of the stretch muscle that reverses the stretch. Efferent impulses inhibit contraction of antagonist muscles, reciprocal inhibition. Afferent impulses from stretch receptor to spinal cord. So these are stretch reflexes. What are small channels that link together the lacunae in bones? These are so we have lamellae, and lacunae are the spaces. So is canaliculi, the small channels. What are stretch receptors within the body of a muscle that primarily detect changes in the length of the muscle? Muscle spindles, muscle spindle apparatus. Changes in the length and rate of change of the muscles are sensed by receptors in the muscle fiber called muscle spindles. So these are receptors, stretch receptors within the muscle, and they detect changes in length of the muscle. These consist of very specialized muscle fibers called intrafusal fibers. These are surrounded by the normal fibers known as extrafusal fibers. If the muscle is stretched or shortened, it is detected by the intrafusal fibers of the muscle. Muscle spindles are buried among the extrafusal fibers of the muscle. Extrafusal muscle fibers are normal contractile fibers. Muscle spindles sends information about muscle stretch to the CNS. Gamma motor neurons from CNS innervate intrafusal fibers to CNS. Central region lacks myofibrils, muscle spindle, and gamma motor neurons from CNS tonically active. Sensory neurons send information to CNS. Gamma brings back motor neurons from CNS. Intrafusal fibers are found in muscle spindles. Extrafusal fiber. Cartilage is it does not have any innervation, no neurons, nor any avascular. It's avascular and aneural. Avascular and aneural. Cartilage is 80% water, lacks nerve fibers, non-innervated. Avascular withstands tension, compression, tough but flexible. Ground substance, collagen fibers, elastic fibers, water. Allows cartilage to rebound after being compressed. Nourishes the cartilage cells. Chondroblasts, these build, produce new matrix. Chondrocytes found in smaller growths within cavities. Lacunae. Nice. What tract is a wide motor pathway starting at the cerebral cortex that terminates on lower motor neurons and interneurons in the spinal cord, controlling movements of the limbs and trunk? Should be the ventral tract. No. Cortical spinal tract. Cortico comes from cortex, spinal tract, upper neuron, motor neurons, anterior CST, lateral CST. We have the anterior here in the ventral front. We have the lower motor neurons here. Goes like that. Corticospinal tract. It's a white matter motor pathway. So it's white matter. Why? Because inside we are white in the brain, right? And then we have the lower extremity trunk. This is the kind of upper extremity face. Corticobulbar tract, corticospinal tract is upper extremity, trunk in lower extremity. Of limbs and trunk, not the face. That's for corticobulbar tract. What is the connective tissue that is firm but flexible? It's cartilage and connects bones together. Bones together. Yes, cartilage. What tract is a two neuron path which unites the cerebral cortex with the cranial nerve nuclei in the brainstem involving motor functions apart from the oculomotor nerve? I mean, we had corticospinal and corticobulbar. This might be corticobulbar, yes. But let's see. Corticobulbar tract controls the cranial motor nuclei that innervate the skeletal muscles of the head and neck. Cranial nerves 3, 4, 5, 6, 7, 8. Sorry, 7, 9. No 8 and 10, 11, 12. So we don't have 1, 2, and 8. Corticobulbar axons descend through the internal capsule and leave the tract at all levels of the brainstem to terminate on cranial motor nuclei. Cranial, they control cranial motor. Cranial like is a head, our cranium, right? Motor, it's a motor movement thing, and nuclei. By nuclei, we're talking about this cell bodies, right, and the nuclei inside it. Corticobulbar tract do not extend much below the medulla, except to innervate the nucleus of 11 in the upper cervical cord. These are really interesting stuff. So it's a two neuron path which unites the cerebral cortex with the cranial nerve nuclei in the brainstem, involving motor functions. What joints are fused together to form sutures? These are immovable joints. What is a series of involuntary rhythmic muscular contractions and relaxations? Frequency summation? No. Clonus. Clonus is a phenomenon of really good demonstration. Involuntary rhythmic contractions respond to sudden sustained stretch. A sudden stretch activates muscle spindles, resulting in the stretch reflex. Tension produced by the muscle contraction activates the Golgi tendon organs, which in turn activate an inverse stretch reflex. This is not to be confused with Golgi apparatus. This is Golgi tendon organs. Inverse reflex stretch reflex, relaxing the muscle. If the stretch is sustained, the muscle spindles are again activated, causing a cycle of alternating contractions and relaxations. Do I have clonus? Here's a test. Clonus is a condition that results in involuntary muscle spasms. Several neurological conditions could be the cause of clonus, so there is a test to determine whether it is clonus or another condition that is causing the muscle spasms. Perform a rapid dorsiflexion of the foot. So dorsiflexion, you flex your foot. Hold the foot with a slight tension with the toes pointed towards you. On releasing the foot, if it jerks over 5 times, it is clonus reaction. On releasing it, if the foot returns back to normal position, there is no clonus present. Similar procedure can be conducted on the wrist as well. Interesting. In some patients, stroking the sole of the foot produces what of the big toe? Often with extension and abduction, fanning of the other toes. This abnormal response is termed as, is this the Babinski reflex? Yeah, my boy. Babinski reflex produces, so stroking of the sole of the foot produces extension, dorsiflexion. So we have of the big toe, dorsiflexion, extension of the big toe, often with extension and abduction, fanning of the other toes. Abduction means they are going away, moving away from the body. And this abnormal response is termed the extensor plantar reflex or Babinski reflex. Extensor plantar reflex. It's the extensor plantar, the plant of your foot. Extensor, nice. Each what contains many myofibrils. This is each muscle fiber or myocyte. What forms a cuff-like structure surrounding myofibril, and its main function is to store Ca2+. It's in the sarcoplasmic reticulum. Muscle contraction begins at the neuromuscular junction, where the afferent neuron releases what? Acetylcholine, which binds to receptors on the sarcolemma and causes depolarization. What is the cell membrane that encloses each muscle cell? It's not the sarcoplasmic reticulum, but sarcolemma. This is sarcolemma. The sarcolemma maintains what, much like neuron does, maintains the membrane potential. What is when only one muscle fiber responds to a brief stimulus? This is a single twitch. Bone tissue is also known as osseous tissue. Precursor summation is the addition of multiple single twitches before the muscle has a chance to fully relax. You can have a tetanus too. In muscles, what adds a phosphate group? It's the creatine phosphate. Adding phosphate to ADP to make ATP. Muscles relax when what is degraded? Acetylcholine is degraded by acetylcholinesterase, terminating the signal. And this is the exact moment when your muscles relax and allow Ca2+ to return to sarcoplasmic reticulum. In neurological terms, what are the spontaneous firing of a motor unit? These are fasciculations. Spontaneous firing of the motor unit. When what reflex is activated? The stretch muscles, stretch reflex, and the supporting muscles are contracted while the antagonist muscles are inhibited, relaxed. Nice. What refers to below normal or absent reflexes? These would be below normal or absent reflexes. Hyporeflexia. What commonly known as floppy baby syndrome is a state of low muscle tone, hypotonia, floppy bone syndrome. Floppy baby syndrome, not bone. Hypotonia. What are stretch receptors within the body of a muscle that primarily detect changes in the length of the muscle? These are changes in length of muscle, muscle spindles. Yes. Okay, I have to go piss, so I'll see you in the next video. Cheers, bye-bye.